How are you, gents? Today, our topic is related switchgear. What is the purpose of the switchgear? So I will present to you guys and the basic informations. What is all about? Shall we start? So first, I need to introduce to you the example of our GIS switchgear. So we have a different company. As you can see here, the photos, different companies, ABB, GE. So if you can see this one, this is bus A and bus B. So, but not at all the same. Depends on the requirements of the client. Okay, but anyhow, we will not tackle this today. We're just only showing what is this. Okay, so as you can see here, this is our example of our single line diagram. So from the 132 kV GIS switchgear, our example that is located in our substation, and then we have our transformer, we have NER, and then we have bus duct, and then the bus duct connected directly to our switchgear 11 kV. That is our downstream, so meaning from the transformer, bus duct, and connected to our switchgear. So you can see here now our transformer from 132 kV to 11 kV, meaning step down transformer. So from high to low, okay? You can see the difference of the number 132 and 11 kV. So from that transformer, so you can see from the top, so what size of the cable that we are using. So based on the calculations, based on the load, that's why we identify the cable size of the transformer from the switchgear to transformer. So how much the length, everything is identified as per the cable schedule. Okay, we're using 3 run by 1 core by 300 mm squared, meaning 3 cables installed with the same cable size. So example RYB, and that is installed via 3 fuel formations. So that is 3 phase formation. Okay, and then is our bus duct connection. So bus duct connections, we have 11 kV, that is 3150 amps, directly connected to our switchgear. So it's simple, guys. So this is the example of our connection. So from the transformer going to our switchgear. So as you can see here, this is our transformer, this is our bus duct with protection cover directly to our cutout. That is behind that is our switchgear. This is switchgear room, okay, or either substation. As you can see here, this is our transformer side, and then this is our switchgear room. So this is how you connect it. Okay, then now we can see here our 11 kV switchgear. So this is our switchgear panel, we can say. You can see the limit, butter limit here. This is our switchgear 11 kV. So example of our transformer, this is our example of our transformer, guys. This is our primary side. So in our primary side, it depends the requirements. This is power transformers. You can see like this, there is a converter. Okay, this is power transformer. So we can use this kind of installation. So termination kit. So Euro mold and a steam mold. So this is the termination kit that we need to install in our cable. How about the secondary side? The secondary side, this is the area. That is, we're using single core cable. That is our secondary side. And then this is the single core cable information. Okay. So example of the switchgear room. So this is our switchgear. So this is basically, maybe you know already what is our switchgear. This is the example. So this is the bus bar compartment. As you can see, this is the bus bar here. You can see the bus bar here, and then see bus bar here. That is as per cubicle. There's a bus bar. This is our feeder. Okay. So now we can see here. I want to cut this one. This is only the information that is now we are inside of our AB switch gear. So this is our bus bar, guys. Huh? This line, this is our bus bar. Okay, 11 kb bus bar. So this square, that is our vacuum circuit breaker. This is our connection. As they have different rating of our vacuum circuit breaker. And then in that below of our panel, as you can see in the example, we have a bottom panel that is our connection where we are entering our field cables. So feeders of the field cables going to equipment. You can see this line. So this is our feeder 1, feeder 2, feeder 3, feeder 4, 5, 6, etc. And then after that, this is our load. Motors, what kind of load transformer, that is our field side. There's a motors, how many kilowatts, it depends on the requirements, okay? And then how much the size of the cables based on the load requirements. So we identify the cable size, okay? So we have a different size of the cables based on the load requirements. That's how we identify. And then that's the time, that's the calculations coming from the engineering. So now the purpose of the switchgear is composed of electrical disconnect switch, fuses, or circuit breakers used to control, protect, isolate electrical equipment. Clear. Switchgears use both the energized equipment to allow work to be done and clear faults downstream. Okay, any faults that can be tripped to our feeder. So what is the components? Conducting components such as switches, circuit breaker, fuses, lighting arrestor that conduct interrupt the flow of electric power. So what is the controls? This is the controls. Current transformer, potential transformer, that is CTBT, protective relays. You can see the relays. They have different relays, but we are not tackling that one because it's a big discussion. Okay, and then that is the function of the function. Switchgear is protection, interruption with short circuit and overload faults current while maintaining service and affecting circuits. Switchgears also provide isolation of circuits from power supply. So this is how the switchgear works. Okay, so now you have an idea what is the purpose of the switchgear from the transformer towards our switchgear, either either 11 kb down to 6.6 down to 415 volts. So step down transformer and step up transformer, and then switchgear different voltage level. Okay, so thank you for your watching, and bye bye, see you in my next video. So don't forget to like and subscribe my channel, guys. Bye bye.